Okay, let's dive right into this explainer. We're going to unpack the invisible infrastructure and the extreme human effort that literally powers our daily mobile connections. You know, we rely on our phones for pretty much everything, right? But how often do we actually stop and think about the physical structures and the intense, gritty physical labor that makes that seamless wireless web possible? Today, we're going to break down exactly how mobile signal towers work, from the literal ground up to the clouds.
So we're really exploring a dual reality here. On one hand, you've got these cold, ultra-precise technological marvels that we rely on every single day to beam data through the air. But on the other hand, we have the gritty, high-altitude reality of the human workers who actually maintain them. It's this wild intersection of cutting-edge engineering and just raw human bravery.
All right, to understand the tech, we've got to start at the bridge, which is the base station. This is the crucial link that takes your phone's radio waves and translates them into actual network data. Whenever you make a call or load a web page, your phone is communicating directly with one of these base stations. Basically, they act as the access point, grabbing your wireless signal and funneling it right into the broader telecommunications network.
Now, just look at the sheer amount of hardware packed onto a single mast. All these distinct physical components have to work together perfectly to transmit and receive signals. Way up top, you've got your antennas. Those are what actually catch your phone's signal. Then there's the base transceiver station, or BTS, which converts those radio frequencies into a digital format. Add in the microwave dishes for remote network connections, miles of heavy-duty cabling, and essential power backups, and you've got a highly complex, totally self-contained communication hub.
Let's trace the invisible journey of a single call. Your device emits an electromagnetic wave, right? The tower's antenna catches it and sends it straight down the coaxial cables to the BTS. From there, that digital signal is routed over to the Mobile Switching Center, or MSC. Think of the MSC as the ultimate traffic cop. It makes absolutely sure your data reaches its exact intended destination, whether that's a server across the globe or just your friend's phone across town.
But there's a massive difference between those giant freestanding towers out on rural highways and the equipment used for urban 5G. A traditional macro cell, like one of those giant lattice towers, can push a signal up to 20 miles across an open landscape. But in a dense city block, those high-frequency 5G signals easily bounce off buildings, so networks have to rely on a massive volume of small cells strategically placed on things like streetlights and rooftops just to handle the heavy data traffic.
But hey, before a single signal can even be sent, a totally massive construction process has to happen. Telecom companies have to navigate this maze of strict local zoning permits and environmental assessments. After that, they literally clear the earth, pour these massive concrete foundations, and assemble tons of steel section by section using heavy cranes. And only after that structure is fully secure do they actually attach the sensitive antennas and run the cabling. So, here is the absolute crucial point. None of this automated magic happens without tower climbers. We're talking about actual human beings scaling lattice structures that pierce up to 1,500 feet into the sky. They're up there to physically install, align, and repair this gear. The technology might be wireless, but I promise you, the installation is intensely physical.
And as you might guess, there's a massive gap between textbook training and the physical reality of the job. Industry standards usually require at least 250 hours of certification training for a new tech. But, you might log those hours in a super comfortable, air-conditioned classroom learning about safety protocols. That is vastly different from the daunting reality of clinging to a towering structure hundreds of feet in the air while battling extreme winds, blazing heat, or freezing rain.
Scaling the ranks in this industry requires some serious, intense self-motivation. A worker typically starts out as an apprentice, directly supervised by experienced climbers. As they log more hours and grab more certifications, they progress up through the technician levels, taking on way more complex troubleshooting. Eventually, the most dedicated climbers earn the title of top hand or foreman. These leaders end up managing entire crews and tackling the absolute most challenging engineering and rigging problems on site.
Now, despite the grueling and honestly dangerous conditions, a lot of technicians absolutely love the adventurous freedom of the job. As one climber noted in the documentary Vertical Freedom, they are far, far away from the monotony of a cubicle and a computer screen. For the right type of person, the constant travel, the unbelievable views, and the intense camaraderie of a climbing crew make this a really, really rewarding career. But make no mistake, the physical demands are staggering. For example, a top-tier foreman isn't just climbing.
They're actually required to develop advanced rigging plans for hoisting telecommunications equipment that frequently weighs well over 500 pounds. 500 pounds! It requires this really advanced understanding of physics, mechanics, and load balancing, and they have to execute all of it while suspended high above the ground.
Yet for all this risk, heavy lifting, and advanced physics, what do you think the average pay is? It's just over $60,000 a year. While foremen can definitely make more, industry analysts note that this estimated average annual pay for a cell tower technician reveals a highly squeezed labor market. The financial compensation just doesn't always seem to align with the extreme physical risks and demands of the job.
According to a report by the Brattle Group and the National Association of Tower Erectors, this economic pressure comes from what's called a monopsony. Basically, it's a market where just 3 massive carriers hold 97% of the power. This dynamic gives a few giant buyers immense leverage over a sea of smaller contracting companies, and the report suggests this keeps labor compensation dangerously flat across the entire industry.
And this economic squeeze is reportedly causing widespread workforce exits. As experienced climbers leave for safer or just better-paying trades, analysts from the Brattle Group warn this could become a critical vulnerability. Think about it. Our cell networks are vital national infrastructure. If we lack the highly skilled human workforce to repair them during a national disaster or a severe weather event, our ability to communicate in an emergency is severely compromised. It's a real national security risk.
To survive the daily routine and mitigate these crazy risks, workers rely on incredibly strict safety protocols. The golden rule? 100% tie-off. There is absolutely zero tolerance for free climbing. A climber must be securely attached to the tower at all times, no exceptions. Furthermore, before anyone even steps foot on a tower, a comprehensive job hazard analysis, or JHA, is conducted just to identify and prepare for every single possible site-specific risk.
So what happens when you climb into an active radio frequency field? Well, beyond gravity, these workers face a unique, totally invisible threat. We're talking about the non-ionizing radio frequency radiation emitted by the very antennas they are trying to fix. You can't see it, you can't hear it, and you can't smell it. But if a tower isn't properly powered down or isolated before a climber ascends, they are walking right into an active electromagnetic field.
And the biological effects of that exposure are no joke. While it's not ionizing radiation, so not like an X-ray, RF exposure can cause hyperthermia, severe headaches, and nausea. It can even damage sensitive tissues in the eyes and testes. Plus, tall metallic structures like elevated work platforms can actually induce electric currents from the RF field, leading to severe electric shocks. This perfectly underscores exactly why mandatory RF awareness training is absolutely vital for anyone working near these arrays.
Making matters even trickier, these antennas are increasingly designed to blend right into their surroundings to comply with local aesthetic ordinances. So, they're hidden inside fake trees, disguised as brick chimneys, or tucked behind billboards. Because of this, workers, especially folks operating aerial lifts or maybe washing windows on city buildings, have to be incredibly vigilant. They need to be fully trained to spot warning signs like an IPAF safety banner that indicate a hidden RF hazard is nearby.
Ultimately, the workers are fighting to make their voices heard. Organizations like the Climber Protection Group are fiercely advocating for the workforce. As their founder points out, telecom companies have these massive, robust teams of lawyers and lobbyists protecting their interests. But individual climbers? They generally don't. So advocacy groups are pushing for actual, enforced federal oversight of contracting and safety practices, rather than just voluntary guidelines, to make sure the people risking their lives are actually protected and compensated. As our society constantly demands faster speeds, wider coverage, and a truly seamless wireless web, this infrastructure is only going to grow more complex. We've got to remember that behind every data packet and every dropped call is a fragile, hardworking human workforce constantly scaling massive heights to maintain our connection to the world. So, what are your thoughts on the balance between our tech demands and worker safety? Next time you see those signal bars on your phone light up, will you think of the cold steel tower or the human hands that built it? Thanks for joining me on this explainer.